This lecture is over bonds and bond valuation. I'm your professor, Dr. Stephen Haggard. First, let's talk about what a bond is. A bond is an interest-only loan. This is different than the loans you are accustomed to, such as home loans and car loans. Those are amortized loans, and each payment on those represents a combination of principal and interest. With bonds, the only payments that are made during the life of the bond are interest, and the principal is returned at the end of the bond's life. And so this makes the bond a different way to borrow than we are accustomed to as consumers. Further, the vocabulary is different for bonds. We say that the issuer sells bonds to the lender. We don't say that they necessarily borrow from the lender. And so if you hear of someone selling bonds, that means they are borrowing. And if you hear of someone buying bonds, that means they are lending. Let's go through some of the vocabulary associated with bonds. First of all, we have coupons. These are the periodic interest payments that are made on the loan. Now, you may recognize the word coupons from those little pieces of paper that your mother would cut out of a lady's home journal to use to save money on groceries or whatnot. And it turns out that the root of these words is identical. In the old days, in order to collect your interest payments on bonds, you would have to cut out little squares of paper from the bottom of the bond and turn it in exchange for your interest payment. And apparently the French word for a little piece of paper cut from a bigger piece of paper is coupon. Today, coupons are actually usually electronic, and so you don't actually see that many paper coupons in practice, but we still call them coupons. Next, we have the face or par value. These are the same thing, by the way, of the bond. And this is the amount of basically the principal of the bond. You'll receive this amount in addition to the last coupon at the last date of the bond's life. The coupon rate is the rate that determines the amount of the coupons. Here's how we use this. We'll take the coupon rate times the face value, and that tells us the annual amount of coupon interest that gets paid. Now you've got to be careful here because most bonds pay interest semi-annually. In order to find the amount of the coupons for those bonds, we'd divide the annual coupon amount by 2. Next we have the maturity of the bond. This is the length of time until the end of the bond's life, until the payment of the face or par value. Most bonds have a maturity anywhere between 10 and 30 years. Then we have the price of the bond. That's what people are willing to pay for the bond in today's market. Bond prices fluctuate based on various characteristics of the market, but the most important one is the interest rate required by the market to hold a bond. We refer to that interest rate as the yield to maturity. Sometimes you'll see it abbreviated YTM. Now, students often get confused between the coupon rate and the yield to maturity. For the great majority of bonds, the coupon rate will remain fixed throughout the life of the bond. It's set at the very beginning, and it never changes. On the other hand, yield to maturity fluctuates constantly. Think about this. If a company issues a bond, and then something happens that makes that company more risky, investors will require a higher rate of return to hold that company's debt. As a result, yield to maturity will go up. The coupon rate, however, will stay the same. It does not change as a result of changes in the market. In finance, we are always concerned about what a financial instrument is worth. So it's time to ask the question, what is a bond worth? Well, recall our earlier definition for the price or value of anything. The price or value of anything is the present value of the expected future cash flows of that instrument, discounted at a rate appropriate to the risk of those cash flows. And so therefore a bond's value is simply the present value of its future cash flows discounted at the yield to maturity. Now be careful here, we're not discounting at the coupon rate, we're discounting at the yield to maturity. And what are the future cash flows associated with a bond? Well, first of all, we have coupons. And typically the coupons are a series of identical payments that go on for a set amount of time. Well, by definition, that's just an annuity, and we already know how to find the present value of an annuity. And then there's that one big payment that you receive at the end called the face value. And to find the future or the present value of the face value is just simply finding the present value of a lump sum to be received at some point in the future. And so we already know how to find the value of a bond. Okay, here's our first bond pricing example. The bond has a face value of 1,000. Now that's our default assumption. I didn't even really have to tell you that the bond had a face value of 1,000, because if I don't tell you, you'll assume that the bond has a face value of 1,000. This bond has a coupon rate of 6%. Now remember that means this bond pays 6% of the face value, which is $1,000, every year in coupons. And it has 10 years left to mature. The interest is paid annually. That means you'll be receiving one coupon per year for the entire amount of interest for that year. Now the market requires a 6% return on this bond. If you see this kind of statement, what they're really saying here is that the yield to maturity on the bond is 6%. And the question is, what is the market price of this bond? Well, we know that price of a bond is merely the present value of the future cash flows. That means the present value of the coupons and the face value. Turns out our calculator is actually pretty good at calculating this for us. There's our TIBA2 plus, and as always we want to do second clear TVM just to clear its little mind. We have 10 years to maturity. Doesn't matter what order you put these things in, but we'll just go in this way. 6I per Y, that's your yield to maturity, the required return by investors. Now the coupons we said were 6% of 1,000. Well, that is 60, and we're going to do payment on that because the coupons are a recurring cash flow. They're actually an annuity. And then finally we have 1,000 future value. If it helps, you can think of that as saying face value, and then you'll know to hit the FV key. Now I believe we have everything in the calculator that we need to compute the present value. Compute present value. Now notice two things. One, there's a negative sign on this, but we know that is simply because of the sign convention for the BA2 plus. The coupons and the face value are both cash flows into your pocket, so that's positive. But you had to pay up front for that privilege, and the amount that you paid was the present value, so it's got the negative number there. Now, the next question is, why is the market price of this bond the same as the face value? It will not always be true. In fact, it usually isn't. In this case, the reason that they're the same is because the coupon rate and the required yield to maturity are exactly the same. That means that the coupons are exactly enough to satisfy investors' need for return. Means they don't need to get any capital gain out of the bond in order to get their required return. Therefore, you pay $1,000 for a bond, collect all the coupons, and at the end they give you your $1,000 back because the coupons were exactly enough to satisfy your need for return. Now this kind of bond that sells at its face value has a special name. We call it a par bond. So if anyone says something about a par bond, you know that the coupon rate is the same as the yield to maturity. You also know that the price is the same as the face value. Okay, here we are with our second bond pricing example. We say that the bond has a face value of 1,000. Of course, I didn't have to tell you that because the default assumption is 1,000. Has a coupon rate of 6% and 10 years to maturity. So far, this sounds like our last example, including the fact that interest is paid annually. The difference comes when we have the yield to maturity being 7%. Now we need to figure out what is the market price of this bond. And second, clear TVM always. Got 10 years to maturity. And this time we have 7 yield to maturity. Coupon is still 60 just like last time. And the face value is still 1,000. And we're going to compute the present value. Once again, the negative sign is just purely because of the sign convention of the calculator. Now my question to you is, why is this price of the bond less than the face value? The bond sells for $929.76 when the face value of the bond is 1,000. And the answer is, the coupons are not enough to satisfy investors' need for return on the bond. Check this out. The coupon rate is only 6%. The market's requiring 7% return. So in addition to those coupons, the bond needs the bond market needs a capital gain on this bond to satisfy the market's demand for return. So that means in addition to the $60 coupons we're going to receive every year, we're also going to have a capital gain of $70.24 over the life of this bond. And the capital gain together with the coupons is exactly enough to satisfy investors' demand for return. Now if the bond is selling for less than face value like this one is, we call this type of bond a discount bond. Now, does that mean that this is a bond you'd like to buy because it's on sale? No. This bond is fairly priced for the coupons and the required return, exactly as fairly priced as the par bond that we just looked at. So just because a bond is a discount bond doesn't mean it's a better deal than another kind of bond. It's fairly priced. Okay, let's try another bond pricing example. Once again, we have a bond with a face value of 1,000, though I didn't have to tell you that since that's our default assumption. It has a coupon rate of 6% and 10 years to maturity. Interest is paid annually. So far, the bond is the same as before. The market requires a 5% return on this bond. What is the market price of this bond? Second, clear TVM to get rid of the old stuff in there. And the bond is a 10-year bond with annual payments, so we can put 10 in there. Yield to maturity is 5 I per Y. Each coupon, as before, is 60. And the face value is 1,000. Now we are ready to compute the present value. And we end up with minus $1,077.22. Now remember that the minus is merely the sign convention on the calculator. Coupons and face value have to be the same, and the price or present value has to be the opposite because their cash flows in opposite direction. But the thing that I really want you to notice here is that this bond sells for more than its face value. Why would anyone pay more for a bond than its face value? Well, the answer is quite simple. The market only requires a 5% return on this bond, yet the bond's coupons return 6%. So the coupons are actually more than enough to satisfy investors' need for return, and so investors are actually willing to pay more for the bond and take a small capital loss on the bond in order to receive those 6% coupons. At the end, this is going to give them a 5% return. They'll have a 6% return on the coupons, and they'll have a small negative return on the capital value of the bond itself, and so they'll wind up with a 5% return. Alright, let's work another bond pricing example. A bond with a face value of 1,000 has a coupon rate of 6% and 10 years to maturity. Now we have a change. The interest here is paid semi-annually, which means this bond pays 2 coupons per year. The market requires a 5% return on this bond. What is the market price of this bond? Let's say second clear TVM. And we want to put in 20 for N. Why 20? Because there are 20 semi-annual coupons being paid. Your N should always be the same as the number of coupons being paid. Now that means we're going to have to make some other adjustments as well. For instance, this 5% yield to maturity, that's per year. Yield to maturity is expressed as an APR, which is merely the sub-period interest rate multiplied by the number of periods per year. And so what we really have here is a semi-annual interest rate times 2. In order to find the semi-annual interest rate, I'm going to divide that by 2, and that's going to give me 2.5%. So I'm going to put in 2.5 I per Y. Now, the coupons are still going to be $60 per year, but they're going to be cut into 2 payments, each worth $30. So we take the annual coupon amount, divide by 2, and that's what we put in for payment. So I'm putting 30 payment. Now the face value stays the same. We don't divide it by 2 because at the end we are going to get $1,000. And now we're ready to compute the present value. And once again we see that this is a premium bond. That's because the yield to maturity is less than the coupon rate. That makes perfect sense. Let's see what else we can see here. Well, the negative, we know that's just purely the sign convention. And so the thing you need to remember when doing semi-annual coupon bonds is that you will double the number of years because you have double that amount of coupons. You'll cut your yield to maturity in half, and you'll cut the coupon amount in half. Everything else stays the same. Okay, now we're going to switch things up a bit. We have a bond with a face value of 1,000 and a coupon rate of 6% and 10 years to maturity. So far it looks very familiar. Interest is paid semi-annually. But now they're giving us the bond price of $864.10 and asking us to calculate the yield to maturity for the bond. Well, the good news is our TI-BA2 Plus can do this for us quite easily. Now, before we even get started here, is the yield to maturity for the bond going to be higher or lower than 6%? Well, at $864.10, this bond is selling at a discount, which lets us know that the coupons are not enough to satisfy investors' need for return. So we know that our correct yield to maturity should be greater than 6%. Second, clear TVM. Hit clear again if you like. Then we're going to do 20 for N because there are 20 coupons. 30 for the payment. That's 60 per year divided by 2. The 1,000 for the future value stays the same. Now here's where things get a little different. $864.10 is the bond's price, but I have to put that in as a negative. Why? Why is the present value negative? Well, it's a sign convention on the TI-BA2 Plus. The present value or price of a bond must always be the opposite sign of the coupon and face value. Now let's calculate I per Y. We get 4%. Is that the yield to maturity? It's not. That's the 6-month rate of return. Remember, yield to maturity is an APR, and we get that by multiplying the sub-period rate times the number of subperiods per year. So we must multiply this by 2 to get the correct answer. I know this must be getting boring by now, but we're going to do another bond pricing example. The bond has a coupon rate of 6% and interest is paid semi-annually. The bond yields 7% and is selling for $973.36. How many years until this bond matures? Now, you may be saying, he didn't tell us the face value. I don't have to tell you the face value because your default assumption, if I do not tell you, is that the bond has a face value of 1,000. So, let's get to work. I'm going to say clear, second, clear TVM. I've got the $30 semi-annual coupons. I've got the future value, face value of 1,000. And the present value of $973.36. Remember, we have to put the negative on the present value. And we have a 3.5 I per Y. Why? Because the yield to maturity for the bond is 7%, but that's on an annual basis, and we need it to be on a semi-annual basis. Now we're ready to compute N. And the answer that I give here is 6. Is that the number of years to maturity? No. Why not? Because everything we've done here has been in semi-annual periods. The bond paid a $30 coupon every 6 months. The yield was 3.5% per 6-month period. And so when we compute N, what we get is the number of semi-annual periods. How do I convert this into years? It's very simple. We just divide by 2, and that tells you the number of years. So the answer here would be 3 years. Okay, one more bond pricing example. A bond is selling for $1,071.70 and has 4 years left to maturity. Interest is paid semi-annually. The bond yields 5%. What is the bond's coupon rate? Well, is it going to be higher or lower than the yield to maturity? This bond is a premium bond, which means the coupons are more than enough to satisfy investors' required return, which we know here is 5%. So we know that coupon rate is going to be greater than 5%. So if we come out with a coupon rate that's smaller than 5%, we'll know we did something wrong. First thing we want to do is clear the TVM. We've got 8N, Y8, 4 years with semi-annual coupons. That's 4 times 2. 1,000 is the face value. We just know that because it's the default assumption. The present value is 1,071.7. Remember to put your negative there. Present value. 2.5 I per Y. Why? Because we have 5% yield to maturity. That means 2.5% per semi-annual period. And at this point, we're ready to compute the payment. So our coupon amount here is $35 every 6 months. Now, could we just divide now by the face value and get the coupon rate? No, because this is a semi-annual amount, so we have to multiply by 2. That gives us basically $70, and we're going to divide by 1,000, which is the face value, and we get 6.999962, which is basically 7%. And so the coupon rate on this bond is 7%. Now, some quick questions. Why did the payment come out positive? Remember that payment and future value should always have the same sign on them because they are both cash flows into your pocket, whereas the initial purchase price of the bond is a cash flow out of your pocket. Now, I didn't merely divide the payment by the face value to get the coupon rate because that payment was a semi-annual coupon. we had to double it to figure out what the annual coupon amount was. Let's talk about how to price zero coupon bonds. A zero coupon bond is merely a bond that pays a zero coupon rate. In other words, all of the money is paid back at the very end. And so your PMT on your calculator is going to be zero. And if you've cleared your TVM, you don't even have to worry about entering it. The weirdness with zero coupon bonds comes in how we price them with regard to the time period. We price zero coupon bonds as though they were semi-annual coupon bonds, even though they pay no coupon. And so if a zero coupon bond has a 6% YTM and 10 years, we would put in 3 I per Y and 20 for N. And that would allow us to correctly price a zero coupon bond. Now occasionally you'll be told to use an annual interest rate, and if you are told, then do so. But if not, you are to assume they are semi-annual. Now why would we do such silliness? Well, it turns out that most bonds pay semi-annual coupons, and the people that price bonds professionally are basically trained to price them using semi-annual coupons. So that's always been the way that we did this. Now, does it have any real impact on the price? It does, because the effective annual rate of that semi-annual pattern is higher due to compounding, and so it is going to affect your price. Let's talk about what happens to the price of a premium bond and a discount bond over their lives. The first thing to know is that they are both going to wind up being worth exactly the same amount of money. Think about the last second of a bond's life. The final coupon's been paid, and all that is left to be paid is the face value of $1,000. And so we know that both of these bonds have to be worth $1,000 at the end of their lives. Since a premium bond is worth more than $1,000, what that means is that it has to reduce in value over its life. And here we see a 15-year premium bond, and we can see what happens to its price over its life. It ends up at $1,000. The opposite has to happen to a discount bond because it currently sells for less than $1,000, and we know at the end it has to be worth exactly $1,000. And so over its life, its value is going to increase to $1,000. Now let's talk about a topic that confuses many students. If you see a question that asks for the current yield, you might be tempted to think that they want the yield to maturity at the current time. But current yield is actually its own concept. Current yield is the annual amount of coupons paid divided by the bond price. So it's not the same as yield to maturity. In fact, it's much easier to calculate. For discount bonds, your current yield is always going to be lower than the yield to maturity because it ignores the capital gain that you're also going to receive as the bond price rises to face value. And for premium bonds, the current yield is going to be higher than the yield to maturity because it ignores that capital loss that you're going to suffer as that premium bond falls toward the face value. So don't be confused and think that current yield and yield to maturity are the same thing. Next, let's talk about interest rate risk. This is the risk that changing interest rates will change bond values. Keep in mind that this relationship will always be the same. As interest rates go up, bond prices go down. As interest rates go down, bond prices go up. I always think it's interesting when I'm reading the Wall Street Journal, which is supposed to be aimed at financially sophisticated individuals, that anytime they have a story on bond prices or bond yields, they always have the statement, bond values increase as bond interest rates decrease, or something along those lines. In your mind, you could picture a teeter-totter. If you have, or a seesaw, If you have interest rates on one end of the teeter-totter or seesaw, bond values would be on the other end. As one went up, the other would go down, and vice versa. It's always like this. It's a mathematical relationship. It's been this way since the first bond was sold, and it will be this way until the very last bond is cashed in. Now, ceteris paribus, bonds with longer times to maturity are more sensitive to these changes. What does ceteris paribus mean? Well, that's fancy Latin talk for all else being equal. So what do we mean here? Bonds with longer times to maturity are more sensitive to changes in interest rates. Why is that? Well, think about this. The present value formula is future value divided by 1 plus r to the t power. That t is the number of periods until the time that you receive the cash flow. So the longer time you have out there, the greater the magnification of the effect of interest rates changes that happens in that 1 plus r in the parentheses on the bottom of the present value formula. Also, ceteris paribus, all else equal, bonds with smaller coupons are more sensitive to changes in interest rates. Why is that? Well, more of the value of the bond is out there at the very end. Consider a bond with the smallest coupons of all, 0 coupons. That means the entire value of the bond is dependent solely on the very last cash flow to be received, the face value. Therefore, all the value is out at the very end, and because it's out such a long time, that bond is very sensitive to interest rate changes. However, what if the bond had big, fat, chunky coupons throughout the life of the bond? A greater percentage of the bond's value or price would be dependent on those coupons which occur earlier in time. Therefore, bonds with fatter coupons are less sensitive to interest rate changes, and bonds with smaller coupons are more sensitive to interest rate changes. Here we have a graphic representation of interest rate risk. We have two bonds. We've got a 30-year bond and a 1-year bond. Now these bonds both have 10% coupons. How can I tell? Well, for one thing, it's written on the slide, but even if it wasn't, I would know, because the interest rate or yield to maturity is the horizontal axis. At 10%, those bonds are both worth their face value of $1,000. Now we know that $1,000 is the default assumption for face value of a bond unless we're told otherwise. So we know these bonds have coupons of 10% per year. Now, we also know that if the interest rate falls below 10%, those bonds are going to be premium bonds. And if the interest rate is greater than 10%, we know those bonds are going to be discount bonds. But the thing we're interested in here is the differential impact of that change in interest rate. Take a look at this. If we cut the interest rate in half from 10%, the bond value for the 1-year bond only increases by about 4.8%. However, the 30-year bond increases by around 77%. Why the difference? Remember, we talked about all other things equal, and in this case they are, the coupon rate's the same. The longer term bond will have greater interest rate risk than the short term bond. On the other hand, if we increase the bond interest rate from 10% to 20%, the 1-year bond only loses around 8.3% of its value, whereas the 30-year bond loses nearly half its value. So we can see that the 30-year bond is much, much more sensitive to interest rate changes than the 1-year bond, and this makes perfect sense. I was giving a talk to a group of clients of a trust company, and these gentlemen were all old guys, and they all had millions of dollars in their portfolio. and they were primarily invested in bonds. And I showed them that, first of all, bond interest rates are mean reverting. This means that historically, we expect bond interest rates to return to their historical average. The bonds that these gentlemen had just bought were yielding somewhere around 3 or 4%. It was very small. And I showed them that historically, U.S. 30-year Treasury bonds were yielding around 8%. And so I demonstrated that if bonds returned to their historical levels, they would lose nearly half of their wealth. I never saw a group of people turn any paler any faster than when I described this to these gentlemen. Now, fortunately for them, at our current point in history, interest rates have actually drifted down further. And so at this point, interest rate risk is on their side, and the value of their bonds have actually increased. Here's an example of interest rate risk in the real world. Back in 1995, I think it was GM issued this 100-year bond, which means that the bond matured in 2095. The coupon rate was 7%, and the price on December 31st of 1995 was $1,000. Well, what does that mean the yield to maturity had to be on that day? Well, it had to be 7% because the bond was selling for face value. Now, July 31st of 1996, the price had fallen to $800. That's a 20% drop. Why did this happen? Well, certainly interest rates must have gone up. And I can personally attest to this situation. My wife and I bought a house in December of 1996, and our mortgage rate was 8%, and we were glad to get it. We thought we got a good deal. To compare that with today's interest rates, my current mortgage is 4.375%, and so interest rates were actually kind of high at the time that this $800 price was recorded, so that makes perfect sense. So we see a 20% drop there because of an increase in interest rates. Now if we move forward to 2007, we can see that the price has increased to 1020.29. What does that mean that the yield to maturity for this bond had to be? Well, it means the yield to maturity actually had to drop below 7% in order for this bond to be selling as a premium bond. And between that 1996 price and the 2007 price, that's a 27.5% increase in bond value. And so when you hear people say, oh, bonds are a safe investment, there's no risk in bonds, they're actually not correct. There's quite a bit of interest in bonds. Even U.S. government bonds, which are considered to be default risk-free, have interest rate risk and are susceptible to these swings in value. Finally, let's talk about reinvestment risk. This is the risk that the future proceeds from the bond, whether they be coupons or the face value, will have to be reinvested at a lower rate of return. Now, bond reinvestment risk sensitivity is the exact opposite of interest rate risk sensitivity. In other words, ceteris paribus, or all else equal, a shorter time to maturity means greater reinvestment risk. Think about this. If you've got a bond that matures in 30 years and has no coupons, that means you are not going to have any reinvestment risk until 30 years down the road. That's a pretty good deal. On the other hand, though, keep in mind that that bond would be extraordinarily sensitive to interest rate risk. Also, larger coupons mean greater reinvestment risk. Remember that for interest rate risk, larger coupons meant less risk. Larger coupons mean greater reinvestment risk because you're getting more of the value of the bond sooner. I'm getting these big fat coupon checks in the mail, and I have to reinvest them. Therefore, reinvestment risk is exactly the opposite of interest rate risk. Shorter time to maturity, and larger coupons mean greater reinvestment risk. Longer time to maturity and smaller coupons means greater interest rate risk.